Okay, let me see. This is not working. Just 1 second. Very good. All right. Well, hello, everyone. Welcome to a Wolfram Language Design Review for version 15. We are looking at GPU functionality. So, Tom, go ahead.
Right. Okay. So in GPU functionality, I want to talk about this is relevant to CUDA. So the goal is to allow Wolfram language to run programs on CUDA GPUs. Okay. Now this does require a CUDA-enabled GPU, which sometimes is a blockage, but I've got
So
a
wait a
plan.
second. So I mean, I have a naive question of modern times.
Yep.
You know, the Apple Metal stack, is that
Does not.
consistent? Oh, so there's
No.
nothing useful there?
This is, well, hold on, just wait. Okay. So, and it uses external evaluate. But, Wolfram Compute Services could support CUDA. You could have a machine that has CUDA enabled device on your Wolfram Compute Service. And so if you do use CUDA on a Mac, you could get a message, use
Yeah, but
compute
that's a
service.
batch. Right now it's batch only.
It's a batch thing, yes, but it's something that's interesting. But this is, CUDA is pretty important, and you can do interesting things with it. So,
But I mean, for example, the new machine learning stuff that we have works natively. That's, torch-based stuff that works natively on all the Mac GPU kinds of things.
right, but it's not using CUDA for that, you
No, it's
see.
not using CUDA.
Right. This
Okay.
is CUDA, which is,
So what you're saying is this is a thing where I can just put a blob of GPU code into an external evaluate cell and just run it if I
well,
have a CUDA
it's
enabled
not in an
machine.
external evaluate cell. It's why don't I show you what I've
Yeah,
what
go ahead,
I've
show
done
me.
with help from I mean, Ricardo's been super helpful with this. Right. So we have to make a session. So we start
I
a
can see.
CUDA session, and so
So
we
let me
can.
ask a question. In terms of
Yeah,
external sessions, ones that are not, just go into a cell, go into a new cell and type greater than sign.
new
Greater than
cell.
sign. Just a greater than sign.
Right.
Just type a greater than sign.
I
No, at
have.
the beginning of the line. Start a new cell. First character you type, a greater than sign. Okay.
Right.
Now look at the pull down, please.
In here.
Yep. Okay.
Right.
What the hell is that thing at the bottom?
Well, I imagine that's there because CUDA's been registered as a
Okay, but
CUDA.
obviously it's a bug.
Right.
There's a giant thing there. Okay,
Right.
so just so I understand, if I no go to that pull down again. Go to the pull down again, please,
Right.
and select the CUDA element. Okay. Now, if you type 2 plus 2 or something here, semicolon maybe. What on earth is that?
Right. I don't know what that is. So I don't know.
Okay.
Well, that's clearly something we should figure out.
Yes.
Clearly, yeah.
So
I mean,
I mean, of things for which you can start an external session, which ones are not interpreted languages?
This is the first one, I believe, which is why
well,
we're running into.
Okay,
hold on.
so
I mean, do we have Ricardo? Maybe you can, speak to that. So,
Ricardo?
What is the question? If this is the first non-interpreted language, I think
Yes,
so.
yes. Okay, so for other languages, there's no notion of starting a session because you're just running a binary.
Yes, there is. There absolutely is.
No, for other
no, there's
compiled languages.
Java's
Oh,
here.
I see. For other compiled languages.
Right, but for Java, for example, go there, go to the greater than sign thing. No, just type a greater than sign at the beginning of a line, please. New line, new cell. Type a greater than sign.
Right.
No, type a great. Well, okay. Now select Java. Okay, now
Right.
type 2 plus 2. I don't know what the line delimiter is in Java. Okay, so this is now starting a session. It's going to run. It's going to return the result, right?
Right.
Okay. So just so I understand, why is that not possible for CUDA?
Well, I mean, maybe it is, but for a start, CUDA programs never return anything. They only work by modifying, memory on the GPU.
So there's no standard out.
There's, well, they can do I/O, but they don't return, the functions don't return anything.
Right, but so like a C program. I mean, like main in a C program just has an exit code.
Yes, yes, somewhat like that. Yes.
Okay. Is there a convention for how uh um okay, so they have pure side effects, basically is what you're saying.
Correct. Yes. Why don't we have a look at some of what we can do?
Yeah, okay, fine. Let's look
Go
at
back
that.
to this. Right. So one thing we can do is so here I can write a program in the Wolfram language and I can compile it to run, it runs on the GPU. So here I can make some arguments. So this is a very typical of a CUDA
Okay,
kernel.
so wait a minute. When it says library function, what is that? How is that? What is that referring to?
Right, so that is very typical for multi-threaded programs, and you have to identify what thread you're in. You see, these kernels run on like
Yeah, but
maybe
what
run
is that library
thousands.
function thing? How did I provision that?
Well, it's an intrinsic, so it got provisioned. You're calling into the CUDA system, and it's telling you what it's identifying
So
what you're in.
in every program in the compiler, I can say library function of block dimensions. How does that work? I don't understand why
No,
anything else
no,
tells
no,
me to.
no, of
No,
course
no. Library function, right? It's a reference to a function in some dynamic library. Now, since we're doing CUDA, we have access to the CUDA dynamic libraries,
Yes.
and one of the intrinsics there is
yes,
block
that's
Okay, so
dimensions.x.
what tells me that add kernel is going to be evaluated against a CUDA library?
well, the fact that I'm running it in a CUDA session. So I'm
I see, but
compiling.
normally add kernel would just be a function, right? So if I say add kernel of 7 or something there,
Right. That's not going to work because it's
well, what's it going to do?
well, you've got to give it, sort of arguments. And
Well,
it's not going to work.
what did it actually say? Could you show that again, please? Okay. Okay. So, I mean, that message could be better because basically what it's saying is you have not started a session. You've not loaded a library that this can
Well,
refer to.
but this is a right, but right, this is a very right general expression, right? I mean, it could be that you wrote right. I mean, suppose I'm writing a function to use my own favorite dynamic library, right? And I mistyped it, right? If it gives me some
Yeah.
message about CUDA, that
No, no,
wouldn't.
no, no, no. I'm not suggesting that. I'm suggesting that the message should be there is no library loaded is not a valid library function isn't a very good message. It's like there is no block dimensions library loaded at this time.
Well, that's the name of a function. That's the name of a function that's
Okay,
been.
fine. I mean that function is not the function is not a valid. I mean,
Yeah,
This is
well,
absolutely a correct message and a
yeah, it is
sensible.
a correct message, but it's not very helpful because the fact is that it could tell me that I needed to have, I needed to be running in a context where that.
But no, you don't need to be running in that context. That's the whole point, Stephen, right? If I then do function compile and
Yeah,
I, point it to right, suppose this is,
I see.
library functions of Itai's favorite function, right?
right.
And, then it's Itai's responsibility to, when I compile it to make sure that my dynamic
Yeah, all
library.
right, okay.
Yeah, yeah, yes, correct. Right. Should I go on?
Yes.
Right. So I have this external function and I can make I have a variety of inputs, but I can make like a GPU array and it runs it and there's the output. So it overwrote this GPU array,
So this
filling it.
call by reference thing that we're doing here is very weird.
Sure.
So what the hell is going on there? You're feeding it in a GPU array, and as a side effect, it's rewriting what's in that GPU array.
That's correct, yes.
So what is out? Could you show me the value of out?
It's going to be a GPU. Right, that's out. So it's a GPU array.
Okay.
And then when I get normal out of it, it returns the data that's, it's referencing. I'm not sure if GPU array
And why is
tells
it
you.
not in order? Or maybe it is. No, I don't know what add. Oh, I see. But it ran it in order.
Yes. Should I
Okay.
go on?
Yep.
Right. So we can do more. I think it's pretty nice that we can write Wolfram language code and execute it on CUDA. So we can use like declarations, all the compiler relevant things. So I can make a function declaration, and then the function references the declaration, and then.
Okay. So for example, if I wanted to write a cellular automaton program here, what would I do?
Well, I would actually. I don't have a cellular automaton, but I would imagine that a GPU cellular automaton would be entirely feasible. So you could write it in Wolfram language. We can also write it in C++. So we can do both of those. Shall I show you the C++ version? This is pretty similar, except now the input language is C++, and I
Okay.
can.
But now how do you actually
and
evaluate that? Hold on. External operation function. What the hell is that? So
well,
why
this
is there
is
an external operation? The
it's
file.
an external operation to make a function. Maybe this could be compile function or something. That might be better.
Yeah, but you should be able to just take text, right? I mean, in both these cases, in
Well, of
principle,
course, yes, I could pass in a string of C++ and do the same thing. And then I can run it and I get the answer.
Is external operation an existing symbol, or is this a proposed
yes.
new symbol?
No,
No, it's
external
not.
operation's an existing one, and it gets sort of qualified for different, external evaluators with various. And I've added a few of these sorts of things that I can show to you. Shall I
Okay.
go on?
Well, let me
Right.
ask a question. Should we
Yeah, go
be,
ahead.
for example, the built-in cellular automaton function, should we be making a GPU version of that?
I think we should definitely explore that. If someone, I don't want to do tons of GPU programming, but if someone had
Well, no,
some.
but I mean, do they need to do GPU programming, or is it just top-level programming with GPU primitives, or something? I mean, in other words, is that simple?
I'd have to see some code to prepare something. So if someone knew, I haven't seen.
I mean, I don't think, right? I don't think if all you know is pure Wolfram language, you can write a successful GPU program. You need to know something about
Correct.
GPU programming.
Yes, I think that's true. Yes, you'd have to write it in a special way. I mean, these things are kind of slightly exotic things. Shall I go on? So.
One thing, not sure it should return an association with function. It should probably just return an external function
Well,
in
the
this case.
problem is there might be several functions in this, you see.
That is a problem in general for external evaluate, but we evaluate the code and you return basically
But supposing I had,
the last one.
whoops, hang on. But I might have lots of functions in this.
There's gonna be a performance problem if you evaluate multiple times.
Well, it's a bit, how do you even know which function you want?
The last one.
The last one. Well, I want this one. I don't want the last one. I want this one.
Well, normally in a language, you know, since it's the last thing that returns, you can define a function and return it. So let's say that you define 3 functions, then the last statement, the last expression is gonna be a reference to this function. So you do add 1 and 2, and then the last statement is gonna be add 1, and this is how you return the last one. At least this is normally what you do in JavaScript or Python or stuff like that. You have multiple definition, but
It
only the
seems
last one.
inconvenient. I mean, we could have another argument to this that says which function I want to return. But it has to all of these get compiled together, you see.
Okay.
And there's a whole bunch of them. There might be, several files that you're compiling. So
Let's go on with the demo. I'm still a bit, I'm just trying to make sure that we're not just supporting, one microscopic corner of one microscopic obscure room.
we are supporting CUDA in a pretty general way. So that's, now you can say that's, there's various things. There's like this underlying code it has type of thing. A bit like the compiled code functions can return these things. Right. So
What was I just showing? What was I just seeing there?
So I have this function that I just compiled. So this is an external function, and then I can get various properties from the external evaluate system by, this is how external evaluate works, as far as I'm aware. So, and it's got various properties that we've connected up.
Okay. All right,
Okay.
we'll keep going. By the way, the @: stuff for data structures, is that implemented now?
That needs some discussion and work.
Wait a minute. It was supposed to be implemented.
I've done some work on it.
Well, there's no front-end support for it yet, so.
So the answer is it's not making it for version 15, is what you're telling me.
Possibly not.
That will be a big shame. That will be a big shame. You really should push hard to make it happen.
Well, okay, right.
That's what we agreed 2 months ago.
We said not. We had a vague idea. I've discussed that.
No, we didn't have a vague idea. We had a very definite idea.
No.
To try and pursue.
No. I've discussed that at quite length with Christopher several times and with Itai. So,
does the idea have problems or what?
Oh yes. There's problems and issues. So yes. I mean, I haven't given up on it, but
well, I mean, okay, that's what we have to do to save the whole data structure effort. To have it not be something which is still in some stupid corner somewhere where nobody's using it.
Okay.
So can we please actually get this done? And if you think you're stuck, get a meeting with me and try and move it forward.
Sure. Okay.
I really don't understand why this is so essential to data structure.
Because right now people are not using data structure because it's so incomprehensible what the hell's going on with stupid subvalues.
And so instead we'll introduce some bizarro symbol which are still subvalues.
They are still subvalues. Okay, let's keep going here.
Right. Okay. So, we have these external operations. So I made a thing called function that's going to return an external function. I made there's a thing called GPU store. So this stores data onto the, so makes an external object where it's storing data on the GPU. And this is useful.
What the hell's the difference between that and GPU array?
Because GPU array has a fairly narrow set of.
So there's some footnote somewhere where you say, well, GPU array doesn't work. Well, why don't we make GPU array work for all the data types?
Well, that would be fine as well. So right.
Better than having to document yet another thing where people have to be confused about, oh, I had a complex number, so I couldn't use GPU array.
Right. Well, GPU array works for complex numbers.
Okay, whatever.
So, yeah.
But what's an example of something which it doesn't work for?
Well, this thing here. So I can't do.
Okay, all right. Well, integer rate, whatever it is.
Right. So that's which might be useful, say, for cellular automata, for example.
Yes, it might.
Right. Anyway, right. So.
But look, saying, oh, by the way, GPU doesn't work, array doesn't work for that. Go use this other obscure piece of functionality is really not a good answer.
Okay, fine. So I'll discuss this with the GPU
If it's
array.
going to be made to work, it should be made to work as part of GPU array,
Okay,
not some
fine.
extra new thing that people have to then learn separately.
Okay, fine. Right. That sounds fine. So we can ditch that. Now, there's also, I think these are somewhat useful, sort of higher level things. So I can do a GPU array. So I have this thing called, so I give it a function and it
Why isn't
runs.
map? Why isn't it just working with map? I mean, why isn't it working with a compiler with map?
Well, because this is the function. You see, it's in calling it has to load this onto the, it's making a special type of kernel and then it's invoking it in a certain way, you see. Or here's another one. I mean, these things actually are quite useful. So this is like table. So I can make table and I can make, sort of, output like this, you see.
This is
It's
unbelievably obscure. It's
well,
unbelievably obscure.
it's actually quite useful. It's
I no
obscure
doubt it's useful if you know to use
because
it.
CUDA is obscure to you. Okay, right. Shall I go on? So,
Yeah, I guess.
I mean, CUDA is probably not something that you're ever going to program with it, but it's embarrassing that we have this huge technology that we're locked out of. And you could say that for any of the external evaluate things. Like, why are we bothering with Python or anything? Anyway, look, this is a packlet of some interesting algorithms that were put together. And some of these are kind of useful for sort of understanding and learning how the
Let me just understand something. We've had a
Yes.
CUDA link forever and ever, right?
This is trying to make CUDA link more, properly documented.
I see. Okay.
The whole point
Fine.
of this is to
Okay.
try
Which,
to make
which Stephen, I will point out, this was your idea. You're like, why aren't we making CUDA link available via external evaluate? And I was like, I think it'll be pretty weird. And as you can see, it's a little weird, but
Okay, fair enough. Okay, so the goal here, just so we're clear, the goal here is, be able to, with enough effort, be able to make use of essentially the functionality of CUDA link in a clean, modern way. Is that correct?
That's exactly, yes, good statement. Yes. That would be useful. That would be a win, I think.
Yes, I agree.
Good. Right. So these are just some of the things you can do with this. So I'm showing here, invoking a copying, kernel. So you can understand, you get some quite good, interesting insight into the card. So I'm doing running a kernel that just does copying of a vector, and I'm running it for two different types.
So what is CUDA algorithms?
It's a packlet of functions, CUDA enabled functions that are useful, that were put together, and it's kind of useful for sort of benchmarking and testing the functionality. So that's what it is.
I see.
So it's just a packlet of code. But this is some of the things you can do. Or here's one. Actually, this was one that I thought was really interesting. So this is evaluating a polynomial. Here, let's just look at it like this. So this is evaluating a polynomial on the CUDA card, which it does in parallel. And so if there's 10 terms, the ratio between the real 32 and the real 64 is a factor of 6. So, and these cards, they massively favor these shorter types. So, and then you can go further. I think this is a nice use of the Wolfram language. So here I'm showing this. This is all done with this functionality. I think it's kind of nice. So if the polynomial has like one term in it, the ratio is 2 because it's spending all its time copying data. And if the number of terms is like getting up to sort of 60, then or 120 is what this is, then the ratio is like 60, which is the theoretical. And so this is actually something I'd never realized, and I'm not sure that it's a way of measuring your algorithm to see whether you're compute bound or data bound. So it's actually quite
Yeah, it's nice. I mean,
all
I
kinds of
think this may not be the
right.
clearest way to say that, but I think you should be.
Fine. Maybe there are clearer ways of,
No, I mean that plot could easily be refactored to make that very clear.
yes, absolutely. But it's got a lot of information in it, and it's not terrible. So yeah. And then this is kind of, you see, this is I think this is kind of neat. So this is in this CUDA algorithms, and I can generate. This is why it's very useful to have Wolfram language for these things, because I can generate the function is like a Wolfram expression. So I can generate different types of Wolfram functions for, quite easily by doing some Wolfram language programming. I can make a function, but then I can go and compile that function for the GPU. So that's somewhat, I think that's
What is
fairly
CURA?
innovative. What is what?
CURA.
CRA that's the type, that's a compiler type that's like a block that we use for a block of memory. So
right.
it's like
it's a void star, right?
no,
Or
it's like an int star or a float
or
star
oh yes, it's a right. It's a type of E star
yes, correct. That's what it is.
in this
Yes.
particular case.
Yeah.
Okay.
I mean, should I show you the document? It's an existing thing in the compiler. So
actually, I vaguely remember this. Yeah.
yep. So it's like a documented type. Or see, it's so useful to write Wolfram language code to be able to do these things. Right. Now, here's a bunch of some more examples. These are a little bit more. So this is one that solves an ODE with Euler method, and I used like an AI tool to get this. So this one here, I can run. So, and this is where the card gets quite useful. So I'm running, this is what the output looks like. So it's not a very good method, and I've run it for 201 points
Yeah.
to simulations, but I could crank these numbers up. So here, and this is where these cards get really useful. So I can, I mean, it takes longer to prepare the data than to run it. So I've generated like 1,000, it did 1,000 things in parallel for 20,000, and that's like the first one. And the input code, this is the C++ code, and then here would be this would be the Wolfram language.
Sorry, show me the C++ code. So that
So it's
contains intrinsic calls to the CUDA stuff, does it?
Yes, that's the same thing. That's
the
same thing that we saw in the other way. Yeah.
Okay.
With getting the block ID and dimensions. It's basically identifying which thread, and then it uses that to index into an output array. So it reads sort of inputs, and then it stores, well, here it's just storing results into the output. And this is very typical of
Fine. Show me the corresponding Wolfram language code.
And then here's the Wolfram language code. So it's pretty similar, really. So, but you could generate this. The nice thing is, the first thing's a string. This is an expression. So I could do preparation work. I could change, these parameters for the, this is the, where is it? This is the thing that's doing the Euler method. I could, adapt that to do, and I could do a more sophisticated thing. But it's quite nice being able to do all this in parallel, massively parallel. So like this machine has about 7,000 cores on it. So, I could run all 7,000 in, concurrently. So that's quite nice. And we've had Fahim's had some other things that he made. Or maybe this was one so he made this kernel by using Notebook Assistant and getting some help. to generate the C++ for this. It's not formatted super nice. But I think I can.
What does it do?
Oh, it does a color conversion, so which is also quite a good thing to do. That the
I have to believe it takes longer to get the data on and off the GPU than to do the operation.
Well, that's why you want to do lots of. That's why you want to run the like the ODE. You want to run lots of steps, type of thing. So yeah, what happened there? Oh, I haven't initialized everything. Sorry.
All right, keep scrolling.
Right. Yeah. So that's yeah. So we use Notebook Assistant for that, and then I just made some notes about these intrinsics. So these are like the thread. These are like the thread operations that we have. And I thought that we could have another function, but if we're wanting to sort of tidy this up, having these threads. So these are very typical for CUDA programs need to have these sorts of things. And yeah, so there's some other intrinsics. So anyway, look,
Okay,
I
so here's
just
a
think we
question.
should clean this up. Right, go ahead. Right.
Here's a question. So first question is, what's the startup overhead for all of this?
The start, right. So it has to start the compiler. So it's not, I mean, I'm running this remotely because I'm on a Mac, and the machines. So I'll demonstrate that to you, but it's running remotely. So just, you know, so even just like running the remote kernel has some
Right, but we
overhead.
don't have yet, compute services is not yet able to do synchronous remote operations.
No, but we could do some batch operation. I think that would be entirely sensible to do something like that. This ought to
For
be
what
working.
purpose? Then you have to keep that. I don't understand how that could possibly work. Then you've got to keep that GPU actively
No,
owned
you
by
would
you.
submit a batch of commands. So you would make your data and run it and get the result. I presume that. So
Right.
this
It would
is
need to be sort of a complete session in one. Otherwise, you're losing the whole benefit of going out to the
right.
GPU by the time you're using network traffic.
Right.
Yeah.
But it's a solution. And if we want to use compute services, we're going to have to be able to do, solve things like that. I mean, this seems right. So you want to see how long it takes. So now I'm starting the session and it's doing some checking, and that's what it took.
Okay.
And this is the first computation. This has to launch the Wolfram compiler.
Mm. Mm.
There we go. Right. It would be feasible to do some of the compilations.
Okay. Let's talk about use cases here.
Right. And then
What can
there's
we really do with this?
what can you
First
do
of
with
all,
it?
unless you have a CUDA GPU, you're out of the game.
That's correct.
Okay. If you have a CUDA GPU, what would you like to have? Function repository entries that contain CUDA code? What would you like? How would you like to use it?
I think some of the I think having some function repository examples that were
No, not
CUDA.
examples. I'm talking about things people can actually use.
Yeah, I think having some real use cases.
What is an example of one of them? What would be a function you would implement there?
I think some of the things that are being moved over to GPU array would be good. So could be part of the roadmap for GPU array. Things
Okay.
could start as they are for other things. So we could have, sorting your GPU array, I don't know, random number generation. I mean,
Wait. Right now, we have a crazy domain-specific language around what operations you can do on GPU arrays. True or not true?
You mean through this technology or through
No,
the
I mean
What
GPU
do
array.
you mean? What do you mean crazy domain specific?
Well, I mean, like, does sort work on a GPU array? I don't know. Right? how would I normally sort a GPU array? Do you understand my question? I mean, what do I do to sort a GPU array? I don't type sort of the GPU array. That won't work. The GPU array is just a creature of the compiled world, right?
Well, yes and no, right? I mean, for the things which have been implemented, right, you just call the function, right? You
I
just
know, but
call sign.
within the compiler.
No, if you want to compute the sign of a GPU array, you call sign of the GPU array.
Okay. And then as a side effect, it changes. So sign of a GPU array doesn't just return the answer. Now, what does it do? Can you show
No,
me
it
this, please?
returns the answer. Look, I mean, you do, you know, and I would do,
GPU array of, yeah, 1.2.3.
right. And then I would do sign. And this is,
What the hell is that?
there's probably some, right. Okay. So I'd probably
Okay,
have
so
to
what
run.
should that have returned? Should that have returned a
That-
value?
It would
Or
return a
GPU
new.
array?
It
This
would
would
have
not
returned a new GPU array.
return a new GPU array, correct?
Okay.
Right. And like transpose and whatever linear solve, right? You just give it the GPU array and it creates a new GPU array for you and returns that.
Yes. Okay. So it's a copied GPU array somewhere else with a different
Yes,
pointer.
it's non-destructive. Right.
Okay, but I just want to walk through what the things you're showing here. People have used CUDA programming in the language with CUDA link.
Yes.
This is a modernization of that. True or not true?
Yes, that's exactly correct. Yes, that's
Okay.
a good
And
statement.
everything you can do with CUDA link today, you can do with this modernized version. True or not true?
There's some very horrible legacy old things of CUDA link that I'd like to get rid of. So,
Well, but the practical app. So let's go look at CUDA link and show me what people have actually done with it.
so what do you want to look
Well,
at
look
with
at the documentation, for example. What do people have? What have people done with CUDA link?
Well, that's not the same thing as this is CUDA link. This has some really ancient stuff that I'd like to get rid of.
Right. So this page is going to say this is now obsolete. Use this.
I think it would say yes. I think it would say
Okay,
that.
so
Yes.
that's what you'll do. Right.
Yes.
So now, wait a minute. On that page, there were a bunch of functions there, which I don't know whether anybody's ever used, like CUDA erosion.
Yeah, I'd like to get rid of those sorts of things. These are kind of yes, I'd like to get rid of things like
so I'm going to ask my question again. What are people going to use this new functionality for? On what machines can they use it? It's machines with an external NVIDIA card. Is that correct?
yes, on Windows
Well,
and Linux.
any NVIDIA card, whether it's internal or external.
Correct.
Okay. Which, for example, doesn't include Mac.
Which does not include Mac,
Although you can put a GPU onto a Mac, true?
but not a CUDA GPU.
Not an ARM-based Mac.
Okay. So what is the analog of this kind of programming for such machines? Is it this metal thing?
No, that's not as rich as this.
Well,
Yeah,
what is
I
the
mean,
analog?
they're developing this new thing called MLX, but it's much less mature than CUDA.
Okay.
I mean, metal is in some ways, but it's much more limited than CUDA.
Yes.
Right.
Okay. So in practice, there'll be some of our users that want to do like, race car type stuff on NVIDIA GPUs.
Right.
And this is for them. Is that correct?
Correct. Yes, I think that's correct.
And
Now, just to slightly muddle, if I don't want to sort of muddle this up too much, but there is an AMD. There are AMD
yeah,
which are quite similar. Their functionality is kind of similar to the so that could work in the same way, but not the Mac stuff. Sorry.
Okay.
Continue. Right.
Yeah. But okay. So I'm just trying to understand here. Basically, CUDA link is quite old, 15 years or more, right?
More 20 years. Yeah, 20 years, I think. But yeah.
Okay. So the point here is this is a modernization of that. Period. End of story. Is that correct?
Yeah, I think that's an idea. I'd
Well,
also
no, but
like
I
it
mean,
to be
okay. So
official.
what's that?
I'd like it to be more official, like so we can document it and talk about it. Not this old stuff that I want to get rid of, you know.
Well,
So
I assume you have a guide page for the new stuff, right?
I
What does
have
it look like?
started to, yes. So I started writing an external evaluate page, just to see what it might look like. Do you want to see that?
Yep.
Or
Yep. And is that basically
well,
so
I'm
I mean,
already on the Python thing, so let's just come and have a look.
I mean, I feel like we'll need more than just an external evaluate page, right? I mean, the current external,
absolutely. I started, yes. Sorry, yes, but
right? I mean, the current things, I mean, basically you just need to know the external language. And here you need to know how to write Wolfram language code that accesses it.
yeah,
And you have a technical issue.
there's some front end screw up here.
Yeah,
That
okay,
means
all right,
You can
fine.
you can do packlet data rebuild and it may fix it, but
I'm going to put another. Right, here we go. I've opened it in a different version. So I wrote this just to have some idea of things like this. But yes, I'd like to write a proper guide page. I think that would be really interesting.
Well, okay, but look,
There are
I'm
model
still trying to
guide
get a
pages.
sense of who's going to
Right.
use this and for what. Okay, so
Well,
I mean, somebody writing highly optimized code for something, if they
mhm.
have a blob of GPU code that already exists, can they plug it in?
If
yes.
yes,
Like Richard has such code for a
if
project we're
he
doing
has
right now on
kernels,
hypergraphs.
he can plug in his kernels. So I mean,
Could somebody talk to him about that, please?
I'll do that. Yes.
Okay, he's got hypergraph rewriting code that's in GPUs
I'll contact
with
Richard.
GPUs. But
Yes.
I think it's intended for use on Macs. So that just takes it
I'll
completely
find
out of
out
this
what
game.
he has. Okay.
Right. Okay. Is this now finished? What you've got, what you're showing here?
I think it's could be considered at a level of finishing. Yes.
Okay.
It's pretty robust. Yeah.
So again, the bottom line is just CUDA link is dead. Long live the new, what's it called?
External evaluate. What do we call it? External evaluate CUDA, or how do we
CUDA
describe
external evaluation.
CUDA
Probably.
external evaluation?
That's what I
Yes.
think. Probably.
Fine.
I mean, and just so I'm clear, if I have a kernel that's written in CUDA, it's just a blob of text. Can I type can I type greater than sign and then select the CUDA thing, stick that kernel in and get anything reasonable back or not?
I don't know. I'd have to think about that.
All right. So the fact that we are putting CUDA in the list of languages that you can type into one of those cells is probably something we shouldn't do.
Yeah, right. Well, obviously, either it should
Okay. All right,
work
fine.
or it shouldn't be
Well, I mean,
listed.
is it meaningful for it to work? You said it isn't because
I'm
it
not
doesn't.
sure that it is, but I'd like to think that through.
All right.
Maybe someone's got some clever idea. Itai, Ilian, Fahim have, Ricardo, you all have clever ideas. But maybe it doesn't make sense, in which case we should remove it.
Right. Well, I mean, I suppose it could try to like auto wrap it and return, the kernel. But right, I mean, I
As a
Could
function.
forgot what the
As an
syntax
external
is, but
function.
do
right
that.
when you
Yeah.
take a blob of code,
And then it
like
would return as an external function. Is that what you have in mind?
right, Right. So if we look at the first example, that was like external session of whatever or external
One here.
yeah, but using C++ code.
Sure. You might want to use Wolfram code, but yes.
Yes.
Right.
But he's talking about pasting things into an external evaluate cell, right?
Yes, yes. No, I get that. Yes.
Right. So if you did that and then you pasted, the contents of that string code equals and, evaluated that, maybe that could be equivalent to, what just
I'm
happened.
gonna have to restart. It's on a separate. I'm running this remotely. Let's just. I think it could return an external function. Another thing that would be useful would be to have a default session as well for CUDA. That might be useful.
Does that make sense? I mean, I don't understand how operating systems, we went through this before. I don't understand how operating systems deal with GPUs, really. I mean, what is that session? Why isn't that session full of CRUD after a while? I'm very confused. Why? Go ahead.
Well, I'm just saying to avoid having to put like session here, to have some way to make that be not necessary.
Well, I mean, we
Maybe-
have a whole session management thing for other languages. I don't know whether that works here.
Right. So what I would like to do is to do that.
Yes. Can't you
Have
do
the
that for other
session.
languages? Yeah, we should be able to do that.
Right.
But other languages, are we using a standard session or are we creating a fresh session every time?
So normally when you use a string, it starts and closes a session. That's the
Okay.
thing.
Fine.
So you
Then
need to
that's what
start
it
the
should do here.
session.
Right,
No,
which would be
that's
useful
not
here.
useful. That's not useful. So either this makes a session or it doesn't work.
Okay, so Ricardo is saying that's not how it works right now.
Fine. So then that there isn't a way of doing it. So you use a session.
So when you do the greater than cell,
Yes, I should be able to do that.
is that always starting and ending a session?
No, that is starting a default session and it keeps it open. But that
Right.
is
So
not
then we could
going.
have So we could have these creating some default session that persists, and then that could,
Right.
wrap
Returning
the
external function.
contents in the code and return an external function.
So you want this Itai, that, and have this selected as CUDA, and that would return
An external function.
function. Is that what you're thinking
Yeah,
about?
right. I'm saying that should be external evaluate session of external operation of function, comma, the contents of the cell.
Okay, which would return an external function, true?
Correct.
Okay, and then how could I use that
I was
external
just being
function?
more precise about which function it returns.
All right. Okay, so if I then say external function of GPU array of something, will it work?
If you're doing through the cell, yes, because basically this guy has a session that is attached. So it will return an external function with a session attached.
I see. So then if I say of GPU array, that will work. The GPU array will get copied to the right place. It'll feed it in. It'll do its thing. Is that correct?
Correct.
Okay.
I didn't quite follow all that, but Itai, maybe you followed that. You could tell me what.
Right. Basically, the claim is that the external function has a reference to the session in which it was created. Therefore, if you take the output of that cell that we're imagining, that external function, and you apply it to the GPU array, then that will work because it's stored as a reference to the session it was created in.
So
You're
the
saying I
GPU
could
array
do
will be
that.
copied into that session and executed, so to speak, on. Correct? Is that correct?
I think it should work. I will need to check the detail, but I think in theory it should work.
But okay, each session, does it have a separate memory space for the GPU or not?
If you create multiple sessions, then they should be in separate memories.
Okay,
places.
so then that GPU array that I created somewhere, or that I just type in at top level, that GPU array somehow has to be copied into the memory partition that's relevant for that particular GPU session, correct?
GPU array just uses a default CUDA context. So
Yeah, but where is it? If an external
I,
function of a
I understand the question, Stephen, right?
okay,
So the question is, how do we know that the GPU arrays that we create and the external function we've created in some session both live in the same addressable space on the GPU? And
yep.
I guess I don't know actually in what memory the external session lives.
I mean, it would be on, if it is the same GPU, you have access to the GPU array. Now, if there are two NVIDIA cards, then the session would be tied to different GPUs.
Okay, so you're telling me that if I create a GPU array, I can go and access memory that's currently corresponding to pixels on my screen. There's no
If you have the reference to it, unless it's some protected way,
yes,
why
possible to do
oh,
that. Yes.
okay.
So you could.
So we've gone back 40 years to no memory protection whatsoever. Yay.
Well, in GPUs. So you could write these CUDA functions and modify, things that the front end is displaying. I think that would be possible. Or
I
read
would
stuff.
recommend it because
Right.
I would
Well,
want to
fine,
crash,
fine. I'm just saying
crash
what
the GPU,
technically,
but yes,
yeah,
theoretically that should be possible, is what you're
yeah,
saying.
that's correct. Yes. Modulo lots of details.
Right. Okay. All right. I mean, this is all a bit complicated for me. And I
I
mean, it
think
will
we
be
should have
good.
something
What's
for
that?
CUDA. And I think this external evaluate isn't bad for
No,
reference.
it's a good mechanism for hooking this
Yeah,
in.
good, good.
I mean, I do wonder what other coprocessor kinds of games can be done with external evaluate. For example, we have all these quantum processing things, which are probably mostly fake, but forget that. That's not our issue. Um, could we use external evaluate for those?
I don't know. I mean, they'd have to not be fake. So
Well, no, they don't have to be fake. They could be running a simulator. It's all
yeah.
good. I mean, the interface is
Well, we've gained some experience with this. And if someone we could, yeah, I know, that'd be interesting.
well, I just don't know.
I mean, some of these I think are research topics or
Yeah.
intern. I think
Okay.
I
Look, the basic bottom line is, and I got to run here, but the basic bottom line is we've now modernized, CUDA link. This is the modernization.
I think that's true. And a lot of users notice CUDA link. When things don't work, we get a lot of messages about it.
Okay. Well, that's good. That's a good sign.
Yeah. I mean,
Okay.
here's one other way that this is absolutely brilliant for is learning about CUDA. It's
Yeah. Okay.
absolutely fantastic. And that's, yeah,
Yeah, that's
absolutely.
useful. No, I agree. That's good. All right. Any
Yeah.
further things we should cover in this meeting?
No, I think so, but this is a go ahead then, is it? This is
I think it's
greenlit.
fine. Yeah. I mean, look, can I, can I certify that this design makes perfect sense? No, I cannot.
Sure, you can't. Right.
It makes my head spin.
Right.
I don't, it is a jungle. I don't know any other analogies I can give. I know the one's head spins much in a jungle, but anyway, it's not our jungle. But
This is
anything that's a
reasonable.
modernization of a 20-year-old thing that where we kept on having to apologize for it is a win.
Yeah, right. Absolutely. I that's very motivating.
Right.
Absolutely.
Right. Sounds good. But so this is now basically finished, and the resources that have been being used on this can be redeployed elsewhere. Is that true?
Well, there's going to be some cleanup to sort of deploy it and documentation to be written and examples
Yes,
and
I
stuff.
understand that. But But other than that, this is a done thing, correct?
Yes. Well, it will be when it's cleaned up and added. And
It will be done when it is done. I understand that wonderfully,
precise.
contentful statement. Okay. Anything else anybody here? Nope. Okay.
Itai, we can follow up a bit on this in the GPRA meeting tomorrow night.
All right. See you guys.
That's good.
Bye.
Okay.